let's have a look and see what's happening on Twitch. We're loading up, loading up, loading up. Well, hey, we're live. Welcome, welcome, welcome to Amberskies with Blades. Hey, that's me. And, well, let's see if anybody wants to join us today. You never know. You never know. You never know indeed. So, what am I up to today? What have I been writing? Let's have a look. We're still on programming GLSL. Hawkey. That sounds good to me. Bit of a good solution. Yeah. Where are we up to? We are up to load or read the data for a shader program. We've got a compile error checker. A checker compiler error checker compile check thing. How do I want to do this? I think we will need some file handler. A file handler. We can't just automatically read the data in. That ain't gonna work. Let's create something new. Yeah. Let's create something new. Game. Let's add a new folder. And we'll just call it core. That's good enough for me. Add new item. I'll take a header file, please, Bob. And we will call it, let's have a look. Yeah, just call it file handlers. File handler. Yeah, I think we can do that. Yeah, that'll do. Add. Let's also include my business. Oh, it's here, isn't it? I can go from the top. Here we go. That's you. Copy. File handler. There we go. That's you done. And also we'll need a CPP file for it, definitely, because this could get extended massively. So that's going to be a new... No, didn't mean to do that. Core, add, new item, thank you. I'll have a CPP file, please, Bob. File handlers. Yeah, we'll add that. And it's just hash include, isn't it? Yeah, that'll do. There we go. And this is going to be a namespace. Game we're using. Good. I've remembered. That's unusual for me. Namespace. And we will have core. Excellent. That looks okay there. Put an extra at the end. That's fine. That's a good setup. That works for me. Leave that there. In the header file, just copy that. There we go. Let's get this microphone in the right place so I'm not struggling. And where's me coffee gone? Oh, I've made myself a cup of coffee and haven't brought it up. Be right back. Here we go. Drinks. Hey, drinks. So, what are we up to today then? What are we up to today? Yes, a bit of file handling. It would seem that we have shaders. Well, that's going to be interesting, isn't it? Because they're on disk or in files quite happily. And that means that we need to read them into our program. They don't automatically appear, which is a shame. Big shame. Wish they did. So text reader is going to need some kind of file system. And then a straightforward read system. Now I've got to make a generic one because we'll need it for loading models as well. I'm going to have text files for models. Blender will do that for us. I think it's called wavefront or .obj files. Blender will export those. We'll have to make some. But to start off with, I won't be using models as such, because I'm looking into terrain, so I will need an output file as well. I think I'll be making that binary, not text. Oh, good news! I've finally decided on the maths for this program, and the decision has been made that I'm not going to write it. I normally write my own maths library. It's just a lot of work which has already been done. So what I did is I found this thing called GLM online, downloaded it this morning. It's only a little diddy thing it's GL for OpenGL and M for maths. Let's have a look at that whilst I'm messing around. So let's have a look. Here we go. So this is GLM. It's got a full manual on it, obviously. That's the manual, yeah. Does it give us a page? It doesn't. Gives us licenses. There is a copyright. The above copyright notice and this permission notice shall be included in all copies or substantial portions of the software. Okay. Yeah, military purposes. I completely agree with that. MIT license, yeah, fine. Which is as is without warranty. Fine, that's okay. And it's looking rather good. The only thing that I didn't check was perspective. Radians, 45F. Okay. So it's in radians. I can cope with radians. I don't see why you'd have to convert it to radians. Two pi radians, 2 pi 6 radians. That should be interesting then. An interesting little experiment in radians going to come up. I can see that happening already. And I can't get this microphone any closer because there's a box on the stand. Okay. What I'm actually interested in here, though, is not the perspective, it was the cross product. And we can get to that using geometry. There's your cross product there on GLM geometry. So I'll be using that in the very, very short future. That's to get me normals. We're going to need normals. Alright, what was I up to? I was going to do some file handling, wasn't I? That was it, yeah. Let's have a look and see what we've got on notes here. File handling. Just read a text file, I suppose. We'll make it string based. And let's just do some standard includes, I suppose. Don't need anything flashy, do we? Not overly. So I'm going to need strings and file streams. So let's pop those two in for now. So that's string and hash include. We'll need the file streams as well, won't we? So that will be f stream, is it? Yeah, of course it will. Such a thing? Yes, there is. Good. Right. Thank God for that. Let's introduce you as a standard library. What do you do? So you're just going to do text storage. As a sequence of characters. I'll probably change this every time I write it, I don't know. This is also from the standard library. Good way of describing it. Just input-output streaming, really, isn't it? Streams to input and output, or from output buffers. I think that's, I'm just going to put it like that because that's the easiest way of doing it, I think. Do I need a class? No. No, we've got this covered by 2 namespaces, but core's a bit general. So really I should only put classes in the core, I suppose. Not entirely sure about that. Let's just move this a bit that way. Yeah, that's a little bit better on the mic now. So let's have some vectors as well. Yeah. Yeah, okay. I like me vectors. So that's standard library. Yeah, dynamically sized arrays. That's a good way of putting it. I'll take that. Because I want a vector, don't I? Yes, please. I want a standard vector, please. No, we'll do that. It will be a standard string, but I want to make a vector of strings. It's not a good idea to keep passing those around, so we can just star it, so we can delete. Okay. Yeah, that'll do. Name it read text file. It'll take in a const standard string, and that will be the and file path. Yeah, path. It's different to file name. If I say file name, I mean it. File path means it. That'll do. Right. Okay. I'm just going to put in what it says. Reads a text file from the given file path. I've got to put file path in there because if anybody's been using Qt or something like that knows there are different types of file paths, especially when it comes to resources. You can have compiled resources with something like Qt. So I'm not going to go that far, but I mean, you can put an SSH file path in there or something like that. I mean, technically, a file path can be many more things than just meaning from disk. So I have to be careful how I word that bit. Anyway, we have a green underscore, and a green underscore means we can click on the thingamajig and it can do that. Yay, I like that. It even returns it for me. Why it puts brackets at the end. No except true. Well, I didn't know that. I've just learnt something. Wow. I can put that to no except true. Well, well, well. Thank you. Thank you for telling me. Get some lines out there. Save that out. Yeah, get rid of that. There we go. So, file handlers. We have started. We have got this. Lovely. Let's see what we can write. It shouldn't be too detailed. I mean, it's only a generic one that we want to do, but even this kind of thing can be technical, I suppose. A little bit, but not a lot, because I want to make it generic. Okay. Add that. Oh, let's start off with making a file storage. So vector, and it's just going to be std : string star. I want it to be a pointer. Call it text file, because that sounds quite normal. Yeah. And this will be storage vector storage array for the text file, for the file. No, I'll just put actually for the text. Good point. Yeah, I'll do it that way. Happy? Yep, I'm happy. That's alright. Let's do the next part then. What else do we need? We are going to need an input file stream. So it's an IF stream. Yeah, it's just come up for me, hasn't it? We'll call it something. In buffer, I usually call it, because that's how I view it anyway. We will have our file path. And guess what? This is ludicrous. This is totally ludicrous. I've got to take it from C++ and put it into a C string. Yeah. Well, congratulations to whoever programmed that. So kind of you to make it ludicrous. Ah, dear. Okay. This will set up I'll say a memory block and attempts to link it with the file. I'll do. Yep, okay. And this is this will just be the file name and full path given by user of the function. That's a better way of describing that one. Magic. Let's carry on then. So now we have an in buffer that's connected to our file path. So what we need to do now is check whether we have been successful in finding the file. And there is a return value on in buffer on IF stream using blah de blah de blah de blah. Is in buffer going to give me a return value or not? It's just std file stream. Okay. Std file stream equals basic IF stream standard char trace char. That just means that's the memory block. Okay, so it's character memory block. Lovely. That's possibly why it needs it turning from a string into a C string. Or character string, which is C, not C++. A char star type string. So while our lovely in buffer is open, is underscore open. Okay, fair enough. Again, that's C. What on earth? Okay. What should we do? I will take a temporary buffer, and it's going to have to be a char because we already know it's dealing in chars. So temp, I'll use underscores now. Stuff you. Buffer. Oh, doesn't have to be big. Pretty small one will do. Yep, that's looking okay. And we're going to while, yeah, another while loop, the in buffer again, but this time is good. Do we have? Is good? No, it's not that, just good. Yes, we have that. Good. There we go. Magic. Now, let's just see what I've done. I've just set up a couple of while loops. So this one here, okay, that one's going to be the stream initiator. So yeah, so that initiates the stream, which was set up above. Okay. I'll do it that way, yeah. This part is that just creates a buffer, a character buffer. Of size 255 bytes, which is 0.25 kilobytes. Yeah. Quarter of a kilobyte is pretty diddy. Pretty diddy by today's standards, I guess. In the old days when I used to program, I would get killed or shot doing that. I'd be limited to 32 or something like that. This is a little bit special. We need to talk about this one. I'm saying is good and not EOF. Normally people would write here not in buffer dot EOF brackets. I'm not going to do that because I want to run this on Linux as well. And on Linux, you can get an end of file marker at the beginning of a file or anywhere inside a file. The end of file marker is not just at the end of the file. So a text file can report itself as empty even though it's got text in it. Yeah. So checking for end of file markers, if you are on Linux, you could get caught out. I'm not saying you will, but you could. From certain programs, that's if you're saving out text files from different types of programs. I haven't tested Blender to find out whether that's the case, so there you go. I'm not risking it. I'm not risking it. Why not program it so it runs on all platforms instead? So there we go. So that is actually checking to see if we have reached the end of the file. That's what it's really doing. So if the in buffer becomes bad, it means it'll stop because the end of file has been reached, or corrupt data has been reached, or something like that. In other words, it can't read anymore. That's really what it means. So now we're checked that we're not reading just gobbledygook, and we are actually inside the file. Let's get ourselves some text. So in buffer. Let's get a line. Let's get a line of text. Yeah, we can do that. We can do it that way. We'll pop it all into our temporary buffer, is it? Char star string star char star, yeah. That'll do us. So I'll stick it in our temporary buffer. Temp buffer. Yeah, that'll do. What does it need to know? Size. Well, I know the size because I said 255. There you go. Simple enough. Yeah, looking okay. Can you get off me? Oh, I hate it when it does this. How do I get that? Escape. Damn thing, get trapped on it. First line, what does it do? It takes the next line from the in buffer. There we go. Next line does what? Well, it just gives the address, doesn't it, really? Yeah. The address for storage. And the last line is max storage, I guess. Yeah, that'll do nicely. We'll have that. Yeah. Then what we're going to do is we are going to take that line and we are going to push it back onto our text file, aren't we? Yep. We're going to add it to our text file. So our text file dot pushback standard string. No, what's 2? Doesn't really say, does it? And val. Okay. It's just going to be temp buffer, but it needs to be new because we've got star. Right, so I put standard string star, so we have to make a new string out of what we have. So it's a new std : string, and that's an open bracket again, which is annoying. What can we have? Oh god, 1 of 18. It's just temp buffer, I know it is. That's it, that's the only value. And that's that. Do I need anything else? No, we don't. Can't see why I would need anything else on that, so I'll put that to the end. Right, what does this do? This takes... so we add to the back of the text file list, or queue you might call it. Or queue. This will create a new standard library string. And that will give the contents for the new string. Address of the contents for the new string. There we go. Yeah, I think we're close enough now with that. I think it's a bit technical. I think it's a bit too technical, this really. Is this beginner stuff? Would you say? Interesting. Very, very interesting. I mean, that's all we've got to do to read a file. I've made a mistake. That's not a while. While, no. If. That reads better. Why have I got a dotted line now down the middle here? Good grief. What kind of rubbish am I programming in? Good, it sorted itself out. That is rubbish. Microsoft, get it sorted. Grief. So if it isn't open, something's gone wrong, hasn't it? Yeah. That'll do. What do we do if something's gone wrong? Dun, da, 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 dun, da, da. Let's get a message going. So, standard library. We haven't got it in, have we? And it's IO stream. And that is standard library input or output to console. Yep, I'm happy with that. Yep, I'm happy with that. Right, now I can do it. So now I can do standard Sierra. Can't return a false. Okay, how are we going to deal with that? We can't do that. That's wrong. Can't do it the way I want to. So I'm going to have to put a comma here. And that has to go. Copy. Paste. And file store. Would that be right? What would I call it? Come on, think of something sensible. We need sensible names for these things, not just off the top of my head. Right. How do you read? Yeah. That's a const. That is a bool. I'm trying to avoid something. I'm trying to avoid putting another one of these exits in that causes a condition. Otherwise, that is going to be very, very bad for everybody. Because that will then be two files that have conditions. I haven't fixed the last one yet. I'm going to have to do it that way. Which means a cat's meowing. That was bad timing there. That really was bad timing. The cat's called Pudding, by the way. Pudding, that was bad timing. You want some food? Is it food time for cats already? Oh, might be dinner time for them. Will that work? The answer is, of course it'll work. That's not the point. The point is I've just opened up a bool. Which that means that is then return true. And this is return false. Good. Right. I'm getting a bit happier with this now. Sorry. I just got to a point there where I was going to make the same mistake that I did last time. And I don't really want to make it. So it's just going to be unable. And it's going to, yeah. Unable to load up. Yeah, whatever. Have we got it as a string, haven't we? File path. Yeah. And then we can just end the line. I prefer doing this on separate lines though. Doesn't follow convention. Okay. std : end line. Yeah, that'll do it. Okay. So basically what we're doing here is we send message to error console. We then follow that message and cause of the error. And of course, at the end, we've just got an end line. And new line. Yeah. Yep, that's right. Yep, that's correct. False equals file did not load. And obviously true equals file loaded. Magic! That's a lot better than it was before. Excellent. I'm a lot happier with that. Just pop those over the line. That's a lot shorter than I thought. That's literally just over a screen. Wow. Magic stuff. I think we've got a text file loader. And as you saw me get around this one by putting the file store as an address, what happens is you give read text file will take in the file path, which is just a string, and it will also take in the address of where you want to store the file. So I could put where to store file there. So when it comes down here, you don't really need this text file anymore, because what you've got is this file store. So that disappears like that, and text file is now that one there. Delete arrow. Expression must have a pointer type. Okay. No instance of overloaded function, standard vector, blah blah blah, allocate, blah blah blah, with string, yeah, matches the argument list and object. The object has type qualifiers that prevent a match. Argument types are standard string star. Object type is const, standard string, vector, standard string, yeah. String allocated, standard, damn it. Damn it, damn it, damn it. There we go. Done it. Yeah, I understand. You can't do it that way. Alright, that's fine. That's fine. It's me trying to protect the address. But that's correct. So they give us the address. We store it at the address that they give us, so they can continue to use their variable as is in their own function. It means that we then get the ability to return a bool of true or false that they can check to see if if there's an error or not. That's better. That is better. That is a lot better than what we wrote the other day. So let's go back to what we wrote the other day in the shaders. And I was very unhappy with it. And it was... What was I unhappy with? Yeah, I haven't got my notes up, have I? That's why I'm looking around for the wrong thing. Shaders.cpp, check compiler error. So, shaders, cpp, check compiler error, has this exit 99. Now, it's a void. Why not make it a bool? It's pretty obvious, really, after what I've just done, just to turn it into a bool. I would have thought that that would make sense. And then, instead of doing this thing here, which is gobbledygook, you just return false. Yeah. So that no longer sets a condition. And that space that I left there comes down to return true. Like that. That now reads correctly. False equals error found. True equals compilation succeeded. Nearly got that right. So the compiler succeeded. Magic. So I've got trues and falses going now. So now we don't have this as a problem anymore. So back in game CPP, I can remove that note. There's no conditions left. Done. Irrelevant. That's just made my job simpler. Oh, hey! Fantastic. Alrighty. Get rid of this note as well. Yeah. Lovely. No to-dos there. And now we have a shader check compile error that will actually return a true or false. If it returns false, then we go into shutdown mode. It all depends where we use this as to where we're going to do the shutdown mode, or how we're going to do the shutdown mode, should I say. Because I'm having problems with that prior. If you remember back in here, this problem here with the destructor, where we couldn't delete things because we hadn't instantiated them. Well, that's what I've got to be careful of when I'm doing functions, that I don't make a function that owns an object. Remember, these are just functions. These aren't classes. They're not owning anything. It doesn't own anything. It just checks. It's just checking something, whether it's worked or not. So this thing actually owns nothing. And again, it's the same with your file handler. This owns nothing. It doesn't even own the file store. So it doesn't own that string. So it doesn't need to... this is owned by whoever's using read text file. So we can just return true or false, and they can respond to it wherever they are. That's a lot better. Damn sight better programming than it was 24 hours ago anyway. 24 hours makes a big difference in my world. We've got a file handler. What does that mean? It means we can now load files, which means we can now load or read the data for a shader program. Yay! Let's do that. That's next on the list. Oh, just stretch me back. So, what I'm looking for is any feedback from anyone who is following or watching in at any time. You can reach me. Have I got my email address up? Yeah, I have. I've got an email address up here on number 7. Contact me there. Everything goes through to my phone. So, is that dead? Nearly. That's cold coffee, never mind. Still got some orange juice left. Yay. So, if anybody's got any suggestions, ideas, or they just want to ask a general question about anything at all, really, to do with programming, or to do with Ultimate Online servers, drop us a line there at DOAC Amberskies. Quite happy to help. Quite open to any ideas you have. Go. Oh, that's that one empty. Oh, I wish every day was like this and I had a successful writing session like that. That was awesome. It's not every day I can actually type in what I think is correct and hopefully get it right. For once I got it right. You can always tell when you get something right because it makes sense. It's when you start putting drivel in, then you've got a problem. Right, we're going to need this as an intermediary. So this is the in-betweener for loading or reading data for a shader program, because we can't use a vector direct. We have to use a certain, well, we have to have a string, or at least a char star, probably, for the shader itself, so it has to be converted. So we can just have a standard string. So we pass the bool back out? Because this part of the program is just a function, it can't decide whether we exit or not. And we're passing a bool back to it. We know that because we've just written the file handler. So it's going to have to be a bool itself. So that settles that. It's going to be load shader. it's going to require a const standard string and file path. Obviously. Are we going to give the full file path or just a file name? File name. And this one, we don't need a file path for that. And we're going to need a file store. Yeah, it's a standard string on this one. Yeah. I'm liking this way of doing it. It's an old C trick to use the input as a return value using the ampersand sign or the address. You see, passing in an address instead of a variable itself or the value of a variable itself. So this is something you don't do in things like Java, where you don't have the scope to use pointers and addresses like this. It's a bit more difficult with Java. Red Hat developers. Oh, okay. Hello, people. They just contacted me again. God knows what for this time. Am I happy with that? Yeah. I think I am. Yeah. Okay. We can write that. Okay, that'll do. So that was shaders H. People say it's very hard to write in two files at once. The answer is no, it's not. It's a lot easier. Especially when it sets it up like that for you. That's the best thing about Visual Studio, is that it does that for you. I think that's the only good thing it does. All these colours are just, God knows what we want them for. But hey ho. I haven't quite worked them all out, what they mean. But, I mean, we get bright greens and dark greens, that's nice. Crimes. Very colourful indeed. Okay, for loading a shader, we've already done the hard work. Yes, we have. We've already done the hard work. So what do we want to do here? Is hash include. And this time it is core, please. And that one there, please. Thank you. Gives functions for loading and saving files. We haven't written the savings bit, but we will do someday. Alright, I'm ready to continue now. I've had a little break. And the cat's set off again. Maybe I should have had me break downstairs with the cat. Kicking. No, being nice to it. So. How are we going to do this? Good grief, how are we going to do this? Okay. So we know that we're going to need a vector. So let's put that in first. Standard vector. We've just written it, so we know that we need it, and it was a standard string star vector. What are we going to call it? The file? Yeah, that'll do. So that is a array for storing each line of the file. That's what it does. Yeah, okay, we're okay so far. No, because I didn't put a semicolon there. Right, so I've got that. What else will I need? Each line. Yeah. Storage for a line of text. Because that's how it's stored. It says it in the middle there. And we're going to need to pull it out to convert it. Okay, I'm happy with that. We're also going to need a bool. So we're going to have a bool. Oh god, what we're going to do is correct. Has loaded. Yeah. Keep track if loading was successful. Is that 1L or 2? 2. Alright. No, 1. I get everything right. Oh dear. It's 1. Doesn't look right to me. Okay. So what's our first command going to be? Our first command is going to be has loaded. Equals, and it's going to be our reader, which is in core, colon, colon, and it doesn't come up because I haven't used a capital. Read text file open brackets, blah-de-blah. And it should now tell me. Constant standard string file path we don't have. I've got file name, don't have file path. So I'll need one of those. That's lucky, because we're going to make one, I think. So we'll put in file path. No, we don't have. And our file store. Our file store is file store. There we go. That's okay there. That's it. And it's going to give me these thingies again where I can't get out of it. Never mind. Right, so everything's got red goobery things on it. I think we could just put file path there. Yeah. Right, that gets rid of the first one. And that gets rid of the second one. No? What? What's wrong with the file store? Standard string and file store search. No suitable user-defined conversion for standard string to const standard vector standard. What? I've got a comma here, haven't I? I didn't put it in twice, did I? Am I that stupid? Yeah, I am. Oh, yes. Doobry me. Doobry me. No, it's me that's wrong. Okay. It's that one. That works properly. It's me using the wrong things. File path, yep, that's right. Yep, that reads right. Oh, I'm happy with that. If it makes sense, do it. So, what we got here? We have a function. Core. What's it called now? File handlers. And really, I should put core. Yeah. So if I hover over that, there you go, it says it on it, reads a text file from the given file path. You not notice that if you hover over something, it'll give you a description, but it also will give you whatever you type in as well. For instance, if you hover over printf, it's got nothing. But if you hover over read text file, oh, all of a sudden it says it reads it. Oh, yeah. Let me just show you something. in game here, where we do window 3D, places a UI window upon the desktop with an OpenGL surface. It says it there, places a window upon the desktop with an OpenGL surface. And it's not getting it from here, it's getting it from the file. It's just I copied and pasted it over because I'm like that. These don't hold anything, do they? You see, it also tells me there as well. That's actually very cleverly done. If I go to clear screen, I haven't put anything on those, have I? No. Naughty me. Anyway, just an interesting fact. It picks up on things that you do. So we're going to load. So if we've loaded, we can continue, I guess. Yeah. So, why return false? It should be return true. That's even better. Has loaded. That's a better return value. So if, that saves us a lot. If it has loaded, we can now check it. And if it has, we can do something. Yay! Okay, so it's going to be a for loop on this one, isn't it? For count. No, int count equals 0. Don't like that. That looks better. For line count equals 0 to line count is less than the file, is it? Yeah. Its size, how many numbers of lines are in the vector, is another way of looking at that. We're just going to pull line count up. I'm just going to go step by step. So it's line count plus plus. That'll do it. That's a nice for next loop. We'll take that one. Line equals. We did put line in, didn't we? Yes. Line equals the file. This makes it look easy. Line count. That's not right. Because a line is a string of characters and therefore automatically a star. It's a pointer. Thank you. There we go. And then we want our file store. Yeah, we do. We want our file store. So that's file store. No. It's dot append, open brackets. In other words, add to the end our line plus \n, please, Bob. Yeah, it's got to have a \n at the end of every single line. Another reason why I need to convert it. Because if it hasn't been included, we have to add it. Otherwise, it's an error. Yeah. And that automatically does everything for us then. That's alright, isn't it? Wow, an auto system. That's going to automatically pick up on everything. So yeah, it is a very, very simple function. But let's have a bit more of a closer look, shall we, from here. So, what do we have here? Function provided by core file handlers. And this is gives the file path and file name to read. And this gives the address. This is the address where the file will be stored. True equals success. There we go, I'll just add that to that line because I've forgotten to add it. Don't need that much space. There we go. So here it's pretty obvious what we're doing. Check to see if the file was loaded correctly. That's okay on that one. How do I describe a for next loop? You can't really, can you? Step through each line in the file. Yeah, I mean this is the best I can do really on that. What we're going to put here. Alright. Yeah. Convert the line from its vector position to a string. Add the line to the end of our storage. Address. Because it is an address. Well, actually, no, it's not. It's a lie. Don't put that in. It's not actually an address. We've just taken a copy of the address, and what we're doing is we've taken control of a variable which goes back to the parent control afterwards. Here is the data to add. That's good. True equals success. false equals an error reading file. So it isn't just failure, it's actually got a meaning. There we go. That is looking good. That is looking very good. I'm on fire today. I'm really on fire. Wow, let's have some orange juice. I think that's a function. And I really would like some coffee right now. Interesting. Interesting, interesting, interesting. I mean, is this simple stuff for people, or am I being too technical? Am I making it too deep, or do you want more information, less information? It's hard to gauge when you're doing things like programming how much explanation you should give. I mean, I could talk for hours on any single line you want that I've just written, all the way down to how the bytes work within the chip and the CPU, but I don't think people want to know that much. If you want to know how to program, it's empty your head and do the programming. I mean, it isn't how do you program, it's how do you become fluent in programming, I suppose. Because we were discussing that with Sil yesterday, and it twigged on me. Yeah, it is really a language. Programming is the language, not the language of programming. Interesting thoughts. Still trying to get some good definitions together for these kind of things. Because it's pretty difficult in English, because English is bendable and flexible and twistable all over the place. I mean, you can see that just by the newspapers. Any language is bendable and twistable. If done, you can do anything wrong. But as you can see, I'm trying to write this in English, and I hope I'm succeeding. I mean, I can't help the std : bits, because that's given with the standard library. That isn't my stuff. But I'm hoping you can see as I'm writing functions and building the functions for use by other functions, it makes sense. Because you're probably still thinking, why did I load a text file in such a fashion when I knew I'd have to convert it? Wait till you see what we use it for next time. Is one of the answers. Because we're going to use the same exact read text file to read in a 3D model. That's how you read a 3D model, or part of it. So it's got more than one functionality within the program anyway. It's used more than once, and therefore it's a function. If it's only ever used once, and it really isn't. I mean, load shader is going to be used twice, because it has to load two shaders. But compile shaders could be, actually. Depends on how I write it. Okay, I really do have cats bothering me now. I've got one clawing at me. So I'm going to go and make myself that cup of coffee that I'm promising myself. Let's just pop that to shaders. There we go. There we go, that'll do. Right, just give us a few minutes. I'll go and make myself a cup of coffee and sort these cats out. Hey, we're back. Good grief. Not good. Cats are happy. Cats are very, very happy. So happy for them. They do look after me though, so I can't be critical in any way. There we go. And let's continue. Continue onwards and upwards into the land of wherever we're going. Oh, I can't remember now. Shaders, yes. Shaders. Create and compile a single shader. Okay. How should we do this one? I think... Right, okay. I think we are going to have to get a bit crafty on this one. Because we are going to need the loaded shader text. And if we do create a shader, it will give us an identifier, an identification number. So let's start off in what I would call normal shader mode, which is an unsigned int. That's what they come in. What's wrong with unsigned? Pardon. Unsigned int. Yeah, got it right this time. Okay. Call it create shader, I suppose. Create shader. Yeah, okay. Yeah, okay, well let's go with the const std : string. And what do we need? We just want the text, don't we? Yeah. No, we don't. We want the and text. I'm guessing. Comma. And I've got OpenGL available to me, haven't I? What does that come as? Okay, I'm just going to call it a GLenum. Yeah, we do have them. Okay, I've got them from that Windows. That's why I need Windows 3D.h, by the way. Gives us all the OpenGL stuff. And that's going to be shader type. We'll need to know which shader type it is, whether it's a vertex or a fragment shader. I'm guessing. Do we need to know that? Yes, we do. As we'll see. We probably will. I hope we will. Because that'll make sense then. Okay, return 0. You can return whatever you want for a couple of seconds, my boy. There we go. Lovely. I'm happy with that, not really. I'm not as happy with that as I am with these two. It's an unsigned int. Do I use an unsigned int? No, no, we'll do it properly. We'll keep it generic, because I don't know what it's going to be on Linux and Mac. It could be different. And I do need the shader type, I think. Or I think. Yeah. Let's have that. And we have create shader. Da, 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 da. Let's try this one then. This is going to be fun. How's it done? Okay. OpenGL. Always start at the beginning. So, unsigned int. I'm just wondering, we used the GL enum, so why don't we just use a glue int? We can. It type defs to the same thing, doesn't it? Unsigned int. Yep. They don't. It's a bit tricky, this one. Do I go into the OpenGL and use OpenGL, or what have we done here? This is all string stuff, so this has got nothing to do with OpenGL. This is all how to read and process char strings and stuff. Addresses, yeah, and stuff. Yes, this is the first time I've ever come across it, really. Okay, we'll use it. So what I'm going to have is a shader. There you go. Equals. Let's get straight to it. GL create shader, please. There it is. What shader would we like? How's about shader type? We did need that, you see. Told you we did. There you are. Done. So what have I just done? What have I just done? GL create shader. What does that really do? It creates space on your graphics card for a shader. Is what it does. And returns an identification number. So reserve memory on GFX card and returns an ID number. Doesn't use addresses. It likes ID numbers. Uses an ID number table. Yep, that's okay. And that just tells the GFX card which shader to use, which specifies the type of shader. Yep. As an OpenGL enumeration. Don't like enum. Enumeration just means that it's a number, but we type in a word. And I don't know what's wrong with that cat. I've just fed it. I don't believe it. Oh well. Can't please everybody, I suppose, can I? So... Okay. Right, this is where we're going to need a bool again, isn't it? And we have to return a shader number. This is where it's gonna... this is... I just don't know how I'm going to do this. I'm going to have to reverse things around from how I've been doing them before, and I don't like that idea. I could put it in the top again. Put that back to bool. But now I'm pushing it. I'm really pushing that method. Because we're doing a lot more in here than just messing around or doing a simple objective. We're now come to the stage where a single error needs us to stop immediately. Ah, wait a minute, we can do it that way. Ah, I've just had an idea. I have just had an idea, which might make sense. So if shader, you've got to check these things, otherwise we're just going to blue screen out of death. This is a problem with OpenGL. You have to check that OpenGL is okay with everything. Otherwise, you can make one mistake with somebody's graphics card, and it's blue screen of death, isn't it? At least the coffee's alright, even if the cat doesn't like it. So if the shader is equal to 0, we can just return shader. But we can do it early. Because there's no point in doing anything else if the shader is 0. So what I'm doing there is I'm checking to see if, not egg, if the shader was registered on the GFX card. It's just a simple safety check. If it's failed, then return shader as a 0. That means we can boil all of our errors down to shader equals 0. That is good stuff. That works for me. Yeah, because that's what the error code is. Don't need to pass a message out at that point. Alright. I think that should be alright. Storage. We need to store the shader text data, because if we don't, it'll get wiped out. I'll show you what I mean. This is a problem with C. We're going to do a C++ to C transfer conversion. but there is a problem with it. If I do it on our text, which we are passing in, it will wipe our text out because the function does that. Very interestingly. This is a talking point, I think. So let's try... return with error code. There we go. That's okay. Finish that one. So let's try explaining what I'm about to do. Let's do it and then explain it. Yeah, that's a better idea. So I'm setting this up in a weird way. I'm going to do a const char star. How big does it need to be? Just one. Let's call it shader source, and we'll just have one of them, please. I need to know its length. So it's shader source length. If we're not careful, we're going to lose a load of data. That's what I'm trying to say. Then I'm going to put the shader source 0 equals what we're going to have, text, yeah, text dot c underscore str. That will wipe text out at the end of that function. That function is a bit of a naughty one, because what it'll do is it'll convert it and then it'll wipe it out. I can't have that because I still need the data to be able to compile it. So I'm having to make a copy of the data whilst transferring it into a C string. If you don't do it this way, then when you come to compile it, you'll have an empty string. You can't use compile text.c underscore string because it will wipe it out as it's trying to compile it. Does that make sense? It's a stupid way that that thing works there. Peak definition. Const no except. Return pointer to null terminated immutable array. There you go. So it just takes the pointers. It's crazy. It's a crazy little thingy. But it can do weird things, as you can see from God knows what all of this lot is doing. Here, no discard. So it's actually the pointer that we are transferring over. If you remember, that shader source is now a pointer because I made it an array. So that's automatically a pointer. So what I'm doing is I'm transferring a C string as a pointer over to there. It will lose the ability to point here to text. Yeah, and if it loses the ability to point to the text, then it can't find the text and it can't compile. Interesting. That's just using pointers. That's probably the most awkward part, is when you start transferring between C++ and C. You have to be a bit more careful when transferring between languages. And remember, OpenGL is in C, and we're writing in C++. Yeah, and C all at the same time, mixed in at this point. This is probably the hardest bit to do. So let's put that shader source length in. And we'll just use 0 again. And that equals... Should have done it the other way round. That equals... Yep, you got it. I've put it as an int, have I? Okay. Don't use an int. I wonder if that's supposed to be a GL char. Mm-hmm. That makes more sense. That's already GL. Yep, that's okay. That's alright, so now I can do it. It's text, but it isn't. We need a static cast. This is another problem with it all. And I want it to a GL int. GL int. Open brackets, and it is text dot size. That should be right. It's an awkward one, that. That is a horrible line. And it isn't size. I'm after the length, aren't I? Yep, we have length as a separate idea. Okay. More complicated than it needs to be, I think. But hey-ho. This is going to be the storage for the open GL text shader text data. Yeah, I can go with that. This one is going to be storage for the length of our text string, character string. So at this point, it isn't a string anymore. It's going to be a character string. Okay. I'm happy now. Yeah, okay. I'll go with that. This is a nightmare. Can I make it any easier? Yeah, that'll do. Store data length in bytes. I hope. It doesn't say, it just says size T, and I hate that. Okay. I can't guarantee that it's in bytes, but I think it is. And this converts. Yeah. Converts our string to C standard char star as open GL is in C. So we've got a conversion, which is an awkward one. But it's a conversion, none the same, and it'll work, so I'm quite happy. Now we've got all the conversions over with, and we've tapped around, danced around the houses. Good grief. Then it's welcome time for any suggestions. That took me years to get right. There you go. My first tries at doing this function many moons ago was a lot longer for some reason, and I couldn't understand in the beginning why it was failing, and even when I had some kind of idea why the function was failing, I didn't really know how to solve it. And it took some doing, I must admit. In the end, I just thought stuff it and just transfer it all across to a different variable. A lot easier. I don't know. So what can we do next? We better tell the graphics card what we're going on about. It's time to tell the graphics card what we're doing, I think. So let's have a look what GL can do for us here. Shader source. Because that's what we're dealing with here, isn't it? Have we got one? Yes, we have. Good. What does it need? Whoa, look at that. Void of perfect. Now the QT company's getting in touch with me. Oh, great. Red Hat QT. Who's next? Come on. No, I ain't giving you no money. PF. Well, FN is function. GL, shader, source, procedure. Pointer to function for GL, shader, source, procedure. And then it does that. So that define, hash define, is a number which points to the procedure on your graphics card. So this procedure is given to you by your graphics card, or, well, not your graphics card, but this is Windows 10, isn't it? It doesn't directly contact the graphics card at all. It goes through what do they call them on here? Those silly things that make graphics card work. God knows. You have to keep downloading them because they update them and everything. Whatever they're called, yeah, them, yeah. Thingies. Yeah, Windows is famous for them, you know what I mean? Has it for every single thing. I'm not even going there. I'll go into a rant if I say the word. So I'm not going to say it. But that points to that pointer is into a program which then points into your graphics card, if you get the idea. Driver. That's it. I'm over. That's it. Walking out of the room. You said that word. Who said that word? Wasn't me. Okay, let's get on with this. Yes, that's what PFNGLSHAD, that's what that means. God help us all. Okay, so what's it asking for? It's asking for a Gluint shader. Wow, we have one of those. Guess what we called it? Okay, I'm happy already. Now, what's it want? A GL size I count. Really? Okay. There's one shader. There you go. How's about that? Const GL char star const star string. Well, that's luckily. What's this one here? How about that one there that we've done here? How about shader source? Does that work? No red squigglies? Okay. Const GL int length. How's about shader source length? Yeah? Magic. There you go. As easy as that. What have we just done? That's the big question, really, isn't it? What have we just done? No, I'll put it on the next line, then it's following on from something at least. GL shader source, what does that actually do? It tells the GFX card about the shader source code. What are we telling? What are we actually telling it? The shaders open GLID, which is what that is. In fact, why didn't I call it shader ID? I don't know, because that's what it is. No, TV, I don't want to switch off. How many hours was that? 2/7? Okay, so it's every couple of hours by the looks of it. It's going to ask me that stupid question. God, I'm going to have to go and find out where it's coming from. That was interesting. One. How many sources of data? One shader, one source. We'll do one at once, thank you. What that means is, when I did that conversion, I didn't actually have to. I didn't have to append and add everything, but I still needed to put that \n on the end, so I would still have had to have done the whole thing. It wouldn't have changed the size of the function in any way, shape or form, except I wouldn't have had to do an append, that's all. Yeah, so I did an append and made it one. There you go. Go figure. That gives us the address of the source code. And so, what's the last bit? The length. So hold on a minute, what have we just done? We've given our graphics card all the information it needs to compile that. It knows the ID, in other words, the reserved memory to use. It knows how much data or how many data sources there are. There's just one. The address of the source, there it is, and the length of the source code. So I've given it all of the information it could ever hope for. Shall we see if it works? There you go. GL compile shader. Oh, look, it's another yeah, I know. What does that want? Gluint shader. What have we just done? I think you can get the hang of this now. What we've just done is I've actually just ask the GFX card to compile the shader. That's what we've just done. The ID of the shader to compile. Easy, huh? Who said OpenGL was difficult? So you give it all the information it can ask for, and then you say, oh, by the way, would you like to compile it for me? But there's a problem. Oh, have you spotted the problem? Well, yeah. I've spotted the problem. I spotted the problem before we started because I went and wrote it. What do we do next? We take a bool. Right, so we need to know if there's an error or not. How do we do that? Well, I think we spent some time on that, didn't we? Are we actually typing out the error message? Yeah, we are actually going to give the error message out. That's fine then, because that's where the info log is. I just wanted to make sure we are actually going to give that out. Error equals... God. What am I doing now? This part here. Check compile error. That's it. The bit that we wrote. So it's check compile error. Open brackets. What did we ask for? Unsigned int ID. Let's try shader. Okay. We're okay so far. Unsigned int flag. This is an interesting one because I've not done this right. It's just shown me that I've made an error. So that's GL compile status. There it is. Which means that flag up here, and we used it here, used to give an OpenGL enumeration flag for status. I'm gonna say that because we can. Because that might just... I mean, that really should be status flag, shouldn't it? Okay. We'll leave it at that for now. What did it want next? Sorry, I've lost track. Come back to me. Thank you. Alright, so we've got our flag. Bool is program false. It's a shader, not the program. We haven't got that far yet. And error message. GL compile shader failed. That'll do. Yeah, that'll do. There we go, that's our check compiler error. Oh. That's going to give true or false. Error equals false. It's got an error. Oh, God. False. True. Any other returns in here? No. Return with no errors. True equals error found. False equals return with no errors. There you go. You see, you can reprogram something just because you get something logically the wrong way around. Doesn't matter. Just go back and change it. Because now we can ask if error. And if there's an error, shader equals 0. So this is simply check return from compiler oh no, it's just return 0, isn't it? So you don't need to carry on. Return no, so exit function returning 0 equals error. That's it. Return the shader ID, which if 0 is an error. Is that it roughly? Can we think of anything else? Not really. I could have just put shader equals 0 and then just let it return shader, but no. I want it to be explicit. Ah, lovely. Return the shader ID, which is non-0. And I know it is. Shaders start at 1. It's stupid, but it's true. Right, okay. That will actually compile a shader. Check for errors. And return a shader ID, which is all you need. Wow. Am I happy with that? Coffee, what do you think? I think I'm happy with that, except for the lack of notes on the check compile error. Alright, check compile error. Check to see if everything went smoothly. That'll do. I'm not really that bothered about this part, so we did it. Shaders, open GLID. Open GL enumeration for compile status. It's actually a number. It's hexadecimal 8881. There you go. If that helps. Fault. Oh yeah, I remember this now. True equals a program. We check a program. False equals we check a shader. There we go, that's that one. Error message if needed. That's better. Now I feel better. Bit clumsy around here, but that can't be helped. A bit clumsy around here, but that can't be helped. Like I said, that append isn't actually needed. You can work around it, but you don't have to. And the tidiest part is the error checking. So the check compiler error is the only part that I actually agree with. All the rest looks still a little bit clumsy, I think the word is. Can that go across a bit more? Yeah, that can. Yeah, that's fine. I'll do. Yeah, that looks better. Okay. I will say that's done. I will say that we have been done. Just check on build. Why does this thing take so long to compile? That looks like a link error. Right, that's correct. That is correct. External symbol bool. Game core. Read text file. Oh, that's right. Because it's not really part of the game yet, is it? What it's just trying to tell me there is that we're not using it. Or we've got the class wrong. One of the two. Which is fine. It's not IntelliSense, is it? It is an error. Yeah, good. Well, at least it's got something right this time. It's where we've gone outside. It's having problems with that there. Which is fine, really, when you think about it. I mean, going over there and actually having a look is because it's not really compiling it. It's not part of anything. Let's just double check. Read text file. Has loaded equals core. Read text file. File path in the file. Standard string, start the file. Yeah, looks alright to me. It's because he doesn't know what to do about this file path business. That's why. We have no file path. We never start with a file path. Oh dear. Oh dear. Right, let's continue. So we can create a shader. We can load a shader, create a shader, compile the complete shader into a single program that we can run on a graphics card. And then we have to look very, very carefully at this last part. And I've got to make some major decisions about it. So actually, this next function finishes it off. The last bit, the shutdown bit, is a little bit more extra because I need to be more careful with what I do. So let's have a look at the end of shaders. The end of time. So we're looking at unsigned ints, aren't we? Could use glue ints for this. No, use unsigned ints just in case. The compiler might get a bit iffy with us. Unsigned int. Whee! How's about... Let's create a shader. Now let's compile them. Well, it's shader singular really, isn't it, at this point? Yeah, compile shader. And for this, all we need is... anything, really? Const std colon string, just the usual, and shader name. I don't know what to call that really, but yeah, right. Let's try that and see how far we get with this. Yeah, go on. I'll give it a go. I'll give it a go. I know there's no errors because they come up in red if there are. Unless my logic is completely wrong, and then we're goofed. And if we're goofed, we're goofed. Let's have a look. So we can compile shaders. This is the entry point. There we go. That's better. Okay. I want those two lines. This is important. I mark it. Right, okay. That's okay. What's this one? Create shader. Next one up. Load shader. Done quite well today. Rather happy with the progress so far. I'm not fast, and I don't really mind. How are we up to on time now? We're at 2:31. Oh, okay. Not doing too badly on time either, which is always good. And compile. Check compiler, yeah. That's looking better now. Okay, so we're all right with that lot. Can't even run a test after this. Normally I can just do a test after this and there's no problem at all. But you can't now. I've put my foot in it. Okay. How can I do this one? Okay. I'll have a glue int. And it's going to be I know what's wrong with that. That's what's wrong with it. Now it makes sense. It's just bothering me because it wasn't really making sense in my head. So very sorry about that. When things don't make sense, I might just go quiet for a second or two because what am I doing? Is sometimes the thoughts I have. Right, we're going to compile a shader program. So let's have a program ID. We're used to it. Yeah, I'll call it an ID this time. We didn't with shaders, so I will this time. It's an unsigned int, isn't it? So it's equals 0. Yeah, go on. We'll put it equal to 0. So that's storage for the GFX card. No. For the Open GLID identifier. Okay, well, lucky. We're doing good now. I want 2 shaders. So what we're going to have is shaders times 2. Nice way of doing it. And our initialization will be 0. Capital L. And we're cooking. Right, does that look okay? Oh no. We've only got 2 of them. There you go. This is... Dun, dun, dun. So what we're doing here... yeah. That's going to be... ID array for our 2 shaders. Vertex and fragment. Okay. And initialize to 0. Nice one. That looks right. So this program ID of ours, let's get on with it. Let's not mess around. Let's just put program ID in equals a GL something or other. It's going to be what, create program probably. Okay, I'm getting nothing now. Oh. Okay. Looking better. There we go. Yeah, we'll go on here. Create program. Really, it does exactly the same as what the shaders did up here. Reserve memory on the graphics card and returns an ID number. How imaginative is that? There you go. That's exactly what it does. And if you put a semicolon after it, it even works. Wow. I never guessed that one, Blades. What should we do next? Okay. What are we doing with create shader up here? Yeah, I can do that. Fine, yeah. Okay. So, shader number 0. Equals. Create shader, innit? What does create shader need? It needs a file path. Well, no. I'm going to be cheeky. I'm going to load it. Can't. Otherwise it will get an error, not the shader. So we need to load it first. Okay. Into a file store. Okay, I can do that. File store is what? Let's load it into a file store, shall we? Standard string. So what we're going to need now is a standard string called file store. May as well. Yep. That'll do me. And then we need to load our shader with the bool. Does create shader do what I think it does nowadays? Unsigned int. Right, so the actual shader figure is 0. Not, yeah. It still does what I think it does. That's good news. So let's start on this one. And load shader takes what, please? File path. Right, file path will be... Where are we? In exec. So it'll be /glsl/ plus shader name plus .vert. Make this a vertex shader. Is that correct? I think it is. Comma. And then we just need a file store string. And we have an error check on that. Okay, I'll sort the error checks out afterwards. Lovely. So now we should be able to create the shader, can we? I've got a file store as a standard string. So what do I need for this? Const standard string text, which is file store, comma, and GLEnum shader type. What is that? I'm guessing it's going to be GL underscore vertex. Vertex underscore shader. Yes. Got it. Fantastic. Yes. So file store will work. Unsigned create shader. And it gives me a shader ID back. Correct. I'm sorry, this is bothering me now. I can't read it properly. I know I'm getting tired when I can't read things properly, but I've got to do it this way. Is that right? Need an error check. Load shader, how are you doing your returns? Ooh, okay. Has loaded. True equals success, false equals error. Where does it come true? Read text file. Right. And we have checked that read text file will do that. Hold on a minute, if you're reading the text file. Where am I? Ah, yeah, that's load shader, sorry. Ting. Hush. Yeah. Success failure. Starts off as false. Success failure. Failure. If has loaded. We do that. If not, we just return the false. Correct. It's looking good, this. Wow. Just following it through to make sure I get it right. Return a false. We have an error. Check it. If error is the wrong way round. Again. If it has not, I don't like doing this. So yes, I've just put a pling in front of has loaded, and it reverses it. So if it was true that it's loaded, it won't trigger because it'll be false. So if false doesn't trigger. If it was false that it's loaded, it becomes true, which will trigger. And it will trigger return 0. And that's exactly it. Because that's our starting point was 0, so we just return 0. Because it needs an unsigned int. You can't go into the minuses, which is a shame. I usually use -1 for an error, but 0's good enough for me. Again, if... Oh, wait a minute. I'm going to do this properly. There you go. That reads better. I don't like the pling. Sorry. Sorry all you shorthand people. Don't like it. If shader ID 0 is equal to create shader, gives us what, a bool or a 0? Unsigned int 0. 0. Then return 0. Why did it just do that? What on earth happened there? Okay. Think through it all. I know I'm slow at these logistics. It's because my mind isn't as nimble as it used to be. Which is true, actually. Shader ID 0, create shader. File store GL vertex shader. If shader ID 0 equals 0, then return 0. I mean, that sounds stupid. But it is correct. Now it definitely needs an explanation, I think. I think I've gone far enough without any explanations now. Because it makes no sense what I've written. And I wrote it. But it's right. You can now see the knock-on effects other functions that you write can have. And how intertwined everything can be, and the logistics of it all can be quite serious if you get it wrong. Well, it's not as bad as it sounds. The only problem with programming is when you don't know that you're getting something wrong, or you don't question that if you're getting something right or not. You've got to be, I wouldn't say negative, I'd say you've got to be very positive about your code, but at the same time you also have to be questioning your code all the way along. That will slow you down. That will slow your productivity down. So what? You know, you don't have to, I'm not under any restrictions on time. Well, I am. When I stop breathing, that'll be time out. But I mean, it's one of those things, isn't it? You see people like punch out tons and tons of code, and you look at it and think, what on earth is that? And it'll take you days to work it all out. Whereas if you look at a piece of my code, it'll take you a couple of minutes maybe at the most. It's not hard to work out, especially when you've got all the messages by the side telling you when I'm being sensible. And I put sensible messages by the side. When I'm not being sensible, the messages can be a bit of a waste of time. But they're still there. They are still there, and I do correct them as I go along. Looks like I'm down to orange juice again. Yeah, I am. So, as you could see, I actually put an extra variable in here to account for what I was doing with the other files, because I was changing all the files and making sure they all read properly. I'm glad I did now. Okay, that is storage to storage for our file loader. That's what that is. This has worked out better than I expected. A lot better. You got to remember, I've never written this code before. Not like this, I haven't. Yeah. Loads and stores our data. Returns error error equals false. Yeah, that's right. Got it now. That's it. This is the full name and file path for the shader. What we do for shader name is we just say color, and it'll do the rest for us. Just makes it easier later on when we get it to compile properly. That's just a repeat of that line. Why have Microsoft put a massive delay on opening up the right click? Watch. Okay, I'll do that again. Click. That's a huge delay. I'm running this off SSD on an i7. And it seems to be fast enough everywhere else. It's just as soon as you try and do a right click, it's like, oh, what? Dopey slow. Left clicking's alright, right clicking's knackered. If check if shader loaded. Return 0 if loading failed. Yeah, okay. What's this one doing in? Create shader. That compiles and stuff, doesn't it? Creates and compiles a single shader, yeah. I'll just put compiles here. Compiles shader returns zero if fail. If failed. Okay. The shader data to be compiled. is in there. Open GL enumeration for the type of shader. Looking good. Fantastic. We're getting through this now. Check if shader compiled. Return 0 if compilation failed. Looking very good. So, we have been able now to load and compile a vertex shader. And we've done it successfully, I hope. I didn't put much in those shaders, I hope, because I'm going to put a lot more in them. We'll see. We'll see. Right, at this point, what do we need to do? Can we reset file store? Soon be able to tell you. File store dot clear. Yes, we have it. Clear. Just means it's reusable. There you go. If you're wondering, the compiler stores the shader on the graphics card. And that's why we need the identity number back. Because without it, we don't know where the compiled shader is. That's what all the shader ID stuff is about. Okay. So now we've got our file store done. All we have to do is that to there. Lazy. Fragment, please. Can we have a frag shape shader? The answer's probably yeah. Can use file store again. Yeah, has loaded. False. Yeah. Create shader. Whoops. No, just a middle bit, please. That turns to a fragment shader. And this is now shader 1. And that's it. That's the difference. Don't have to alter anything on here. What am I pressing there? The wrong key. There we go. That's lovely. So that's shader 0, shader 1 done. What do we need next? I know, I cheated. Hey ho. So we've got a vertex shader and we've got a fragment shader. I'm just thinking, no. No, I can't do what I was just thinking. That would be silly. Better mark that in before I forget. Alright, let's do a for loop. It's shader count equals 0. And shade. What do I need it as? I'll just have it as an int. Doesn't matter on this one. Shader count is less than 2. Shader count plus plus. Whoa, plus plus. Looks good. Looks very good. We'll take that for a ride. Because all we're going to do is a GL attach shader. And that's going to take program and shader. So program is program ID. And its part is a shader ID. Open brackets, shader count. There you go. That's it. So we attach the shaders that we have generated to the program, which is a good idea. As you can see, we use the shader IDs and nothing really to do with the file store. The file store is now used and dead. I could zero it out again, but it's going to get killed anyway at that bracket. And once this scope's ended, that bracket, it gets deaded anyway, so, and resources back to the system, so that doesn't matter. The memory goes back to the operating system anyway. So that's fine, we can leave that alone. I'm just trying to think if there's anything else in here. Once we've attached the shaders, there's not really much more to do, is there? Yeah, okay. No, I'm not doing any more. I don't think on that one. I'm just gonna do it. You see, they've been compiled. So all we've done is we've attached two compiled programs under one program ID. And now what we're going to do is we're going to link everything together so that it works, just like you would do with a C++ program or a C program, because that's really what it is. Shh, don't tell anybody. It works in C-ish, sort of. So let's link it. I think we can, can't we, at this stage? I mean, yeah, we can. Yeah, we'll link it. So, what we got? Yeah, it's just link program. And it's just going to be program ID, isn't it? Yep. Can't see why not. That's all it's asking for, isn't it? Yep, that's all it's asking for. Okay, let's note that up. How are we noting our 4 next loops in this game? Yeah, okay. So this will be step through each shader ID. Step through each shader ID. What does this actually do? Ah. Okay. I'm a bit stuck for an answer on that one, so let's try open GL. GL attach shader. What do you actually do? Kronos group. What do you say you do? Specify the list of things that will be linked together. Program objects provide this mechanism. Shaders that are to be linked together in a program object must first be attached to the program. So just attached. So attach shaders to program object is what it does. Attach shaders to the program object. I don't know why they call it an object. I suppose it is. Could be. Theoretically. Has attach got an E at the end? No. Attache has. That's what I was thinking. That is the program objects ID. That is the shader to be attached. Shader ID to be attached. Lovely. That makes some kind of sense. Link the shaders into the final program. Yeah. Went through a lot, didn't we, to get here? But we got here. The resulting... Oh no. The program for linking. That's better. Getting ahead of myself. Because I've still got stuff to do, yeah. If you remember, don't trust OpenGL and your graphics card. Check everything. Remember we did a check compiler? Yeah, we did, didn't we? Last time we checked the compiler was somewhere up here, wasn't it? And it does give an error value back, which is good. Okay. That's alright. This is going to be GL compile program failed. So really it's just this. It's this part here again. it's not going to be shader, it's going to be program ID. So it's going to be program ID. We'll put in there. Yeah, we'll sort that out in a minute. Is it compile status still? No, it's link status, isn't it? We've just linked. We're well far away from getting to where we want to be here. True. It's a program. And this will be not shader, but program. Okay. It's starting to look reasonable. Check to see if everything went smoothly. Shaders. Program. Programs. OpenGL ID. OpenGL enumeration for link status. I even spelled it wrong in the last one, so it's link here. Go to the last one. It's compile. Yep, that looks better. Thank you. Link status, true. We check a program. False. Yep, that's right. Error message if needed. Yep, I'm happy with that. Lovely. If error, return 0. Now what do? We do exactly the same, but we ask our graphics card. So if we can't detect an error, we still ask our graphics card if it can detect an error. Yeah. So there we go. Validate program. I don't think that's going to be using much except for program. Lovely. Oopsie daisy, don't do that. So this part here, well, basically the same as the last part. Ask the GFX card if the program is valid. Got to be very careful how I word that. And of course that's the program ID. OpenGL program ID. Lovely. Guess what? If you notice, there's a problem. There's no return on it. So we have to go and we actually have to go and fetch the return, as it were. And we can do that, funnily enough, by using this. Yeah. And that's why I wrote it. Because could you imagine writing that lot out every time? I want me IVs and want me info logs. Get lost. I don't know. So this time, what are we doing? We check the compile error. Check to see if everything went smoothly. Are we using the program? Yes. What are we doing this time? Validate status. Validation, I suppose it should really be. Validity. Validate status. and that's for, I'll spell it right, validation status. True, yep. Error GL validate program failed. There we go. And that will give an error message if needed. And if an error is returned, we exit the function with 0. Otherwise, we're gonna return, hooray, the program ID. Nice one. Nice one. That's OpenGL for you. That was a lot of through the hoops, that one. And you can see now why I wrote the first bit last. Because otherwise I could not have written the check compilers. And I certainly could not have written the loads and the creates. But everything's used multiple times, which is why I needed them. I mean, could you imagine putting the create shader and load shader code in here? This file would be slightly more than 234 lines long, put it that way. You'd be heading on up for about 500 to 1,000. Yeah. Don't want to go there, don't want to be that, because we still haven't finished. And now we come to the problem one. Shut down and delete shaders. Well. Oh my god. Have I got anything on that or not? Do I have anything on that? I might, if I'm lucky, have a cleanup. Okay. Let's call it void shader cleanup. Okay. Or should we have a bool? No. It's just a void. And we're going to call it shader cleanup. Oh no, shader shutdown. That was it. Now I remember. There's no variables required. Yes, there are. Damn it. I need the shaders and the shader IDs. You're joking me. I've got to save all of this lot out somewhere. Okay. So it's going to be shader shutdown. GL. I think they're all uints, aren't they? Yep, GL uint. Program. Yep, GL uint. All GL uints. Okay. GL uint. Program. Comma. GL uint. Vert shader ID. Ah, yes, let's do it that way. Yes, program ID. Vert shader ID. And GL uint frag shader ID. You see, we'll have all of this, will we? We won't have the IDs. We need to store the IDs. We need to store the shader. I'd never thought about that. That makes this a class. Wow. It's a class. Shaders is a class. Oh my god. Yeah. I wasn't expecting that one. I really wasn't expecting that one. Well done, shaders. You're going to be a class. Right. How do we turn this into a class? The only things that we are interested in is the IDs. We're only interested in that, and that. The rest of this doesn't matter. The only input we need is a shader name, and we can get that through compile shader program. How many shaders do we want to store? I want to do two, don't I? I want one for colour, one for texture. So at this point we can do this. There we go. Multi-shader programs. Can't do that, because we don't have those two variables available to us outside of compile shader. Compile shader program is the only part here that knows about the shader IDs and the program ID at the same time, even if it returns a program ID. At no point have we stored it anywhere else, and when that hits, everything in here dies. So as soon as this returns the program ID, all of these other variables that we've made up here, any variables that we've made like file store, program ID itself, will actually copy out its value. So program ID, shader ID will all die. Will all go back to the system. If I make a class, we can have multiple shaders. And we don't need, yeah, we do really need to compile a shader and send it out, don't we? So having a class, I mean, this class, what's it actually going to do? Every time a shader is asked for, it's going to increment by 1 and give us a new shader. Shader count. Yes, we can do that. These are uints, aren't they? Yeah. We can do that. Wow. Such an idea is coming together. Right, I'll leave that alone for a second or two, though. Because that wasn't what I wanted to do today. I just wanted to complete the shaders. Didn't really want to turn it into a class today. Let me put that on my notes. Shaders to be turned into a class. Fantastic. I never actually thought about it that way until now. That matches everything else. But that doesn't help me pass the problems here. Let's have a look. So we've got shaders now. What would happen if I was to give compile shader program the name of color? Now remember, I'm going to wreck my graphics card doing this, because we haven't got a shutdown yet. What order is the shutdown? Because we've got returns out of this at early stages, haven't we? Or do we? Was I good about that and I didn't get the return outs until here? I want to see what it says. I don't really care about my graphics card. I can always reset my computer afterwards, can't I? So if I was to, just for testing out purposes, if I was to say hash include, for example, would not advise anybody doing this. GLSL. Just realised something. I've just realised something. GLSL shader.h. This can give a false, can't it? And if it gives a false, it's just going to crash out. Can return zeros. Okay, I think I can do this safely. To a point. Can't do until after context. Which is there. Okay. You shouldn't do it until after context. Bool. No, it's not a bool. It's gluint. Yep. And it's going to be a shader program. Equals. And it's going to be GL. No, it's not. It's going to be game. Colon. GLSL. Colon. And it's going to be compile shader program. That's the line. if everything succeeds, we won't know. Shader. Just actually put it on a separate line. Shader. Do it properly. Shader program ID equals percent %d, comma, this'll bugger everything up, won't it? Shader program. Okay. What do we think? Huh? What do we think? A gluint going into a printf. I doubt that'll work. I'm going to try and compile it anyway, I don't care. Build. Do I need to put file handlers in here? No. It's in shaders.h. Right, you should now be able to build that. Has loaded redefinition multiple in there. Yeah, okay, that's fine. Yeah, done multiple. Yeah. That's fine, I don't mind. Has loaded, yeah, I have done that. It's a multiple definition, so it's a copy and paste error, that, which is unfortunate. I don't like copy and paste, and that is what happens. What was the other one? That one as well. Yeah, take the bool off. That's what it means by redefinition, is I've called it a bool twice, where we've already declared it as being a bool there. So it already knows it's a bool. We don't have to tell it again. I know, it's silly little things like that. Build. Rebuild, please. Give me it from scratch, baby. Give me all the link warnings as well this time, because if you come on screen, I can show you how to deal with them. Come on. Yeah, we've got the warnings. That's good news. Allocator. Vector. Basic string. Trait. Standard. Blah. Allocator. Bleh. Da. Allocator. Bleh. Ah. Anybody know what that means? I'll come back to you. You're too hard to read. Output. There they were. Link, warning, linker, default lib, libcmt conflicts with the use of other libs. Use no default lib. Thank you. You absolute pain in the butt, Microsoft, for that one. Can we have properties open and output open at the same time, please? Thank you. Can't be hard to do your Windows now, can it? You've been practicing for 25 years. Lib. Linker. Input. And which ones do we want to do? The laughable ones, most likely. So we'll have libcmt and MSV. Oh dear, this one cracks me up. MSV CRT. Microsoft Visual C Runtime Library. Okay. Thank you for that. Link. Unresolved external symbol. Bool. Game : core. Read text file class. Const and comma class. Oh dear. That's come out badly. That has come out very badly. Is it the constness that's buggering it all up? I think it is, you know. But it is definitely the... Doesn't mind the bool. It's something to do with the way I've done it. Yeah, I agree with that. Something to do with the way I did it, yeah. Very funny. Nice one, Blades. So it's file handler.h I want. Doesn't like the second one. That one. That's what it doesn't like. I put too much constness in my standards. Yeah, took it out of here, didn't I? Typical. Right, if I do a rebuild now, it should not come up with those link errors. Why is it taking so long? There you go, succeeded. Yeah. Glue 32 doesn't have any PDBs, mate. I didn't do any. And I'm certainly not going back to 140 or something to do. Oh no, I can do it on this one, can't I? Ah. I could do them. Nah, can't be bothered. There you go. Everything that I typed in, there was one mistake. Sorry about that. I left on the header file in here a const where I shouldn't have had one. My bad. I should have spotted that earlier. Alright, this is where the fun really starts. Building C++ is one thing. All that means is that I typed it in very carefully. Doesn't mean it works. Shall we have a look? There you go. Any idea why? It's the correct answer. So what we do is we go over to our pathing and find out what on earth is going wrong. So here we put our pathing in. I did it right at the bottom, didn't I? Oh dear. Blades, you so silly. Here we did it. Okay. Let's try that. Do you think that's right? I'm doing this on purpose, don't worry. I know the answer. I spotted it when I was doing it and then hesitated and thought, no, I've made a mistake, I'll go with it. Okay, we're going to try again. Done. We have a shader. That was it. If you're not impressed by that, you're absolutely mental. that shader program's off my hard drive and just read in like that. Perfect. Well, why are there so many bugs in Windows 10? I wonder. I could rant about that, couldn't I? Ooh. Bugs. There are no bugs. There's only bad programming. And that is the cleanest programming I've done in an awful long time. Now, to show you that it's working is even worse. I've now got to go and alter a shader. Let's take... no, let's take the fragment. Fragment's always best one. Shh. Don't tell anybody. Let's save that out before Blades finds out. What happened? No, I wasn't wasting my time with all that erroring, was I? So, compile shader failed. Fragment shader failed to compile with the following errors. Error is at 0.13. It actually gives you the line after. That's where the error is. Syntax error, parse error. Which means basically there's something wrong with that. And the thing that's wrong with it is there's no semicolon. So no code was generated. One compile errors. Shader program ID 0, correct. And it's error number 273, which says syntax error, parser error. No, that's number 132, sorry. 273, I don't know what 273 is. There you go, you'd have to look that one up. The answer is, of course it's an error, there's no semicolon. But thank you, thank you, thank you. Blades bows. And we can't shut down. We've got to leave it running now, because there's no shutdown. It will have to run forever. Yeah, right. Still on my graphics card. But hey-ho. And that is how you make a shader. And that is how you test a shader badly. I'll just pull that down. So, test is okay. So yeah, we can run shaders. Oh, wow. That is amazing. That is absolutely amazing. So, shaders, color, Windows, file. What would I have down the bottom here? Oh yeah, shutdown. Program, plus program GLSL, error checks, shutdown, GFX card. No, I needed shutdown in shader program. I'm not carrying on like this. I can't keep putting it like this. I want to put it in the program. I want to program the first part of the graphics now. And I can't without a shader. You can't program graphics without a shader. I mean, it's just fucking ridiculous. So we've got core, we've got display, we've got GLSL with shaders. Okay. So that has to be made into a class, and then we have to start on terrain. I'm going to call it terrain. The game board. However you want to put it. Yeah. So, we'll try that. We'll try that tomorrow. I'll look over the class later. I might do that off screen and just show you how to put it into a class. No, I'll do it on screen. It's messy. It's messy. And I think that should be that. Yeah, I'll catch you tomorrow. Tomorrow will be... we've done the error checks. Graphics card shut down, haven't done. GLSL. Create into a class. Right, I'll do that. Yeah, lovely. And then we'll do that terrain piece, and we'll get it on screen and floating around a little bit. That should be fun. It's quite easy, isn't it, this program? But yeah, that's how you... Well, you don't... That's not how you use it, but that's just an example to make sure that everything's working. Otherwise, I think that's it for today. If you've missed out on the tests or anything like that, I've run all the tests, they're all good, and I wish you all farewell. I've been on now for 3 hours and 50 minutes. I would like you all to take care for the rest of the day, and have fun. We're done. Ta-ra for now.